if it is problems, but I'm not gonna allow others to have it. Okay. How many of you? 77. We need 103 people to join. So please join everyone quick as possible. Can you let know your friends to join quickly? There are 20 more people to join. Okay, I'll start anyway. Let them to join in between. Okay, good afternoon, everyone. Hope you all are good. And we are meeting around after 2 weeks apart. But anyhow, we have finished our lectures, last week lecture beforehand. So it is okay for us. Okay. So in this, so now still we are in our chapter 1. So here we have finished our, let me start my things. Okay. Okay, so we have finished in the chapter 1 itself. We have finished all about the number system and errors. Okay, so I hope you have tried the homework quiz 1 possibly. Okay, so please in between times, please refer the full notes as well as the homework quiz, as well as today the first day itself you take the past papers as well, so you can understand how we can have to answer in our semester questions, how these questions are formed in our semester papers. So it will be very easy for you. Anyhow, after finishing these things also, our continuous assessment will have at last. So anyway, it's better you to prepare yourself beforehand. Okay, so next one, this is our, we are in our lecture number 3. So it is our section 2 of chapter 1. Okay, I have named in that way. So it is a solution of equation one variable. So here we're gonna see some methods to solve this equation. We can see each one by one. Okay. So okay. This and okay. So this is our lecture note of 3. I have sent you already. So you can use that one, as well as all your important things will be here anyway. So I have sent you the notes that is easy for me to go a little faster on these writing and things. But all your examples and explanations and extra things will be here. So you have to be more conscious on the lecture itself. You have to be with you have to be with the lectures anyway. Okay, so let's start our chapter 1. Chapter 1, section number 2. So it is named as solution of non-linear equation in one variable. So anyway, in that heading, we have named as solution of equation in one variable. Okay, anyway, there are situation we can have two variable as well. Okay, x comma y. So here we everything we're gonna look out the equation which has the one variable. For example, x only or y only, any variable, but only one. Okay, in that equation itself, full algebraic equations, it must have one equation, one variable. Okay, it can be non-linear. Most probably here we're gonna study about the non-linear equation, because in the linear case, for example, if you have 2x is equal to 5, anything. Okay, so you know how to solve this one, isn't it? So x equal to 5 by 2. That's all. Okay, this is a solution for this equation. So you have to know there are two things. If it is something stopped here, we call this as the expressions. Something expressed. I hope you have known this one in your first year, first semester cases. Then if it is something equal to something, or either you can write this one as 2x minus 5, which is equal to 0. These are called as the equation. So there are two kind of things we can involve. This is the expressions. This is the equation. If we are involving the equation, we call it the equation. So in this case, the linear case, we already know in even the other, ED, PD also we have seen. So if it is the power is 1, we call it as a linear case. Here also, if it is a 2x 1 is equal to 5, or even if it is 2, here we're gonna involve one variable. Say two variables, linear case, 2x plus y is equal to 5, something like that. Okay, so these are two variable, more than two variable, maybe plus that or anything. Okay, these are all the powers are 1, therefore we're gonna have this as a linear case. But here this is obvious, we have know everything about it, so we don't need to analyze that part. So here we're gonna mostly consider about the non-linear. That's why the heading has been used as a solution of non-linear equation in one variable. Okay, so let's go through and learn something how to solve these kind of equation. Okay, so I think these notes are available in your notes as well, so you don't just consider what it is. So it says the problem of finding a value of x. Okay, here they are taking that one variable as the x most of the case. Okay, so the problem of finding a value of y which is 0 of a functions occurs frequently. So if it is problem of finding a value which gives the function's value as a 0. Okay, so let's see what it is. Then let's say that value of x which giving the function 0 we called as a alpha. Okay, here we're gonna tell that alpha is the value of x where we can find the functions. If you put that value into this function, it will give as 0. That's what it says. Okay, the problem of finding the value of x which is 0 of a function. Okay, it occur most of the cases frequently. Then that alpha, the value of alpha is said to be root. I hope you have heard this word as well. Okay, root of the equation. It means the solutions. Okay, root or solution. Okay, that is the solution of the equation fx equals 0. What are they saying is, for example, if the function f of x 0 or any function, okay, where we are finding a root alpha, when you substitute this alpha into this f of x for x equal to alpha, if you substitute in this whatever the equation has given, you will have a 0 as the function value will be 0. Then we call this alpha as the root of the equation. Okay, root of the equation. Okay, so also they say root of an equation can be, okay, second point. Root of an equation can be complex or real value or finite number or infinite number. So we have seen some, for example, x equal to, let's say 5 by 2 is a root, then it is a real number, isn't it? Real can be, or sometime maybe some situation if you are dealing with a complex variable, let's say my answer will be 1 plus 2i. Okay, we know I is a complex variable. I is equal to square root of minus 1. Okay, these things we can study later also. So this is we called as a complex number. Similarly, finite number means something we can count. For example, 1, 2, 10,000, 100,000, like that. So infinity number means we don't know what it is, but there is a number we called as a infinity that we can't say as accurately. So we called as a infinities. So there are the roots can be taken any of these format, complex or real, finite or infinite. Okay, so that is what they have talking here. Next, so let me give you one example. For example, let's say here we are dealing with nonlinear equation. No? So nonlinear equation can have something, the power maybe more than 1. Okay, more than, for example, 2. For example, let's say my function is x squared minus 2x plus 1. This we already know known equation, isn't it? So what do you call these kind of equations? Anyone knows how we name this kind of equations of power 2 equations? Can you answer me in the chat? Power 3 equation can be named in one way. What we call these equations? Anyone? Yes, good. I got one answer. That is correct. Algebraic equation for yes, yes. So it is an algebraic equation, you know. Okay, algebraic equations is correct, but it is the power 2. I'm asking for power 2 equations are called. Yes, I got so many answers. Thank you very much. So it is called as a quadratic equation. Okay, quadratic equation. Yes, anyone talk with me? Please send a message. Don't talk. Okay. Quadratic equation. That's fine. Okay. So the power 2 equation we called as a quadratic equation. Maybe sometime, let's say my gx can be x cube minus 5x squared plus 3x minus 1. Anything. Okay. So what we call this one? So power 2 will be quadratic. This can be say power 3 will be another name. Anyone? Can you remember? Yes, good. We got one answer. Others? Power 3 equation can also be called as fill in the blank. Okay, good. At least I got one answer. Okay, it's called as a cubic. Yes, another one. Okay, fine. Cubic equations. Okay, so it goes power 2, power 3, power 4, anything. So these all are called as a nonlinear equation. So this kind of equation, the for example, if fx equal to x square minus 2x plus 1 or anything. Okay, so this is called as a quadratic equation of power 2. Okay, so we know how to solve this one, isn't it? Already in school level we know there is x equal to minus b. If you equal to 0, if you wanted to equal to 0, you can take this one, b square minus 4ac over 2a, those kind of. So how about 3? The 3 also a little bit okay. How about fourth power, fifth power, sixth power, any power? Okay, nth power. So if you wanted to solve and find a general idea, this only available only for two, can be four, but fourth and fifth and sixth and more than that, more than three, that is a difficulty, isn't it? So far they didn't find a equation I mean easy equations. But here we're gonna find how to solve these kind of equation using some techniques. So some people have found already. So we're gonna study that one and we can use this one for our solving. Okay. So that's what our purpose of today's lecture. Uh, okay. I hope you all are okay. So let me continue. So okay, I'm not finished yet. Okay. So in that case, so f of x equal to, so x squared minus, let me take my same one. Okay. So can you tell me what is a root? You already know, isn't it? So can you tell me possible answer for this one, root of this one? You already know these stuffs, so we can find the answers. Can you tell me root? What is a root? Can be this one. Yes, let me see. One, I got one answer. Yes, yes, good. Okay. Okay, these are very, school things, isn't it? So we know this will be 1, 1. So both are equals. Okay. So see here, I wanted to explain you this part. That's what I am doing. Okay. So I have found my alphas are 1, 1. Let me take only one. Okay. Anyway, whatever the alpha I put, it will be given same answer. No? So I'm going to take alpha is equal to 1. So if you substitute this alpha is equal to 1 in this equation, in these expressions, okay, so x is squared, so 1 is squared, minus 2 times 1 plus 1. What is the answer? 1, 1, yeah, 1 plus 1, 2, 2 minus 2, 0, isn't it? So I can say alpha is a root. Okay, that's what they are saying. The problem of finding a value of x which is 0 of a function occurs frequently. That alpha is said to be a root of the equation of this fx equal to 0 if f of alpha is equal to 0. So if they given this expression, anyway, we're going to find out for the equation of 0, no? So that's what we have done, no? That's how we have found this root. We equate this 2x plus 1 is equal to 0. Then we solve by that equation we have found, isn't it? So that's what they say. For the function, they are equating to 0. Then they are substituting that alpha into that equation. If you're getting 0, they're saying this is a root of these equations. Okay. I hope you all understand these concepts. Okay, let me continue now. Okay, this is where we're gonna start our actual lecture here. Okay, so there are several numerical methods available to solve nonlinear equations. So which are we called as a bisection method, Newton-Raphson method, and fixed point iteration method of false version. So today, hopefully we'll finish these two. Okay, and we can take this out in the next class, hopefully. Oh, let's see. Okay, so let's see one by one and how we can use these methods and understand what is this method, and then how can we solve these nonlinear equation using this method. This is our concept today. So let me continue. First of all, we're gonna see the method of bisection method. Okay. Okay, tell me, you have heard this word bi. So what do you mean by the bi? You have, I also told you many times, and you have bi means, let me see, I got, yeah, good, good. Okay, so you got that, isn't it? It's a 2. By means, it's a 2. Okay, sorry. Okay, give me a second. Okay, so by means, bi, not a by, okay? This by means 2. So bisection means what? So you can take this word and do two, like a 2 word, okay? By and sections. What do you think? Section means? We already talk about this one, no? This section, I'm telling this is my chapter 1's section 2. So what do you mean by that? Yeah, good. Okay. So part. So we're gonna divide our things into two part. Okay, two part and finding the idea. That's a fundamental idea. Anyway, let's see what it is. Okay. Okay, let me continue. So bisection method. The bisection method is based on the following theorem on continuous theorem. Okay, continuous functions. So this bisection method is working by this theorem. This is a important theorem. Okay, sometimes it may comes. So let's understand it clearly. So no need to memorize. Okay. So for it is, you have to keep it in mind. This is kind of a bisection method, and it is talking about under this theorem of continuous functions. So we are not talking about the other kind of functions. We're going to talk about the continuous functions. So what do you mean by continuous functions? Continuous functions. So something like this, no? It has no break like this. Okay. So if you are talking about a function, it has something like this, no breaks. Okay. So that's what we're gonna talk about under the continuous functions. Okay. So the theorem says, assume a function f belongs to CAB. This is how we have to read these theorems. Okay. Hope you all now okay for reading these things. Okay. Assume that the function f is belongs to CAB. Here C we call as continuous. Continuous in the interval of a comma b. So this is a closed interval, isn't it? So if it is this one, we call as an open interval. This is a closed interval because it is closed under this. We're going to talk about our function within this interval only. Okay, that's what they say. The function is continuous in the interval a comma b, and that there exists a number r. We're going to find out like alpha. We're going to talk about one number r, which is also belongs to not this one. Okay, cut out this c, only c a comma b. Okay, it means r belongs to a comma b such that if you put the r into that function, you will have a 0. That is, we already know, no? We have seen in the earlier also. So that's what they say. Assume the function is a continuous in this interval a comma b. So you know a is what, b is what, isn't it? So this side, the starting point is a, ending point is b. So here we know a may be less than b. Okay. So in the number line, if you talk about this is number line of x, then if you take this interval a comma b, a is always less than b, no? Okay. So if you find one r, okay, we're going to talk about this r again. Okay, this r, if you substitute that r into that function value, you will have a 0. Okay, then it continues. Okay, it's not yet finished. Then if FA and FB, what do you think? FA and FB. Can you explain what is FA and FB? We know what is A and B. Okay, this is the interval. So can you tell me what is FA and FB using this one? Can you tell me what it's talking about? Let's see, I got, okay. Can you answer me? What is FA and FB? No, I'm talking about what we are doing. No. So what I said, if I find one R, what I'm doing here? No. Can you explain what I am doing with that A comma B? to get the FA and FB. No. Okay. So nobody answered correctly. What I'm asking is substituting. Substituting A to this functional value, substituting B also in the function. Okay. You have got something wrong. I mean, different answer. That is not what I mean. Okay. What I meant is this is not coming. Okay. So if I have one R, when I substitute to this function f of R is equal to 0. Likewise, if I substitute this A to the function value FA, if I substitute B is FB. For example, let's say my A comma B is 1 comma 2 or 0 comma 1, let's say. Okay, let's my function fx equal to x square minus 2x plus 1 or anything. Okay, I think it won't give the answer anyway. Okay, our meeting will be finished within 10 minutes. Please join again. Okay, so let's leave that one. Okay, so now, so for example, if x equal, let's say, for example, 2x minus 5 or whatever number, okay? I don't know whether these two are solution, root or not, but I'm just telling. So f of a means f of 0. So I just substitute 0 into this, and this will be 0, this will be 0, minus 5. Similarly, fb, what is my fb? F of 1. So 1 is squared plus 2, 2 times 1, minus 5. So 3 minus 5 will be minus 2. Okay, so this is what I'm meaning. So you have to substitute your interval values to the functions f of a, f of b. Have, see, the theorem continues. Okay, if you are substituting the functions, sorry, the value of fa and fb, if you are having different opposite signs, for example, let's say this is my a, this is my a, this is my b, this is positive. Let's say after I substitute, I get here positive value, here negative value. Okay, so both are opposite, no, not same. You don't get plus plus or minus minus. Both should be opposite. So if this is also okay, or otherwise if you get here plus sorry, here minus and here plus, this is also opposite, no, this is also fine. So you have to find these values opposite sign. Why? Because they are telling is always they won't give you a comma b. Sometimes you have to find yourself. So that in that situation, you have to put one value. Let's say I'm going to take 0 comma 1 for this. And if I put C, this is minus, this is minus. So these two are not my case. Let's say I can put, can you find, okay, my pen is not, okay. Can you take A comma B, 1 comma 2, see whether it is obeying or not. See whether you are getting opposite signs or not. If it is meeting finish, you join again, okay? Can you try and tell me? I'm erasing. Try 1 comma 2. See whether you get opposite sign or not. Let me take my f of x equal to what I have taken. X square minus 2x, is that? Plus 2x minus 5, whatever, okay? Can you try for a comma b of 1 comma 2? See whether you get plus opposite sign. So let me try also. F of 1 will be what? 1 square plus 2 minus 5. So this will be 3 minus 2. Okay, I got 1 minus. Okay, how about 2? So this will be 2 squared. 2 squared plus 2 to 4 minus 5. So 4 plus 4, 8. Yes, I got it, no? So I can take this as interval. Sometimes they will give you what is a comma b. But if they don't give you, you have to analyze like this way to find out whether when you substitute these values, you have to get the opposite values. That's what they mean. Okay. Then this Cn represent the sequence of midpoints. We will talk about what it is generated by the bisection process. So in this method, we're going to talk about the opposite sign as well as the midpoints. Midpoint means what? For example, If I am getting these two opposite sign, then I'll find my other C, let's say C1 or C0, my first C midpoint, A plus B divided by 2, no? That is my midpoint, no? Am I correct? So let's say this is my 1. I couldn't write correctly. Okay. This is my 1, this is my 2. Okay. So what is the midpoint? So if you add these two and divide it by 2, you'll get the midpoint now. So that is what they are talking. These will be maybe C0, C1, C2. We're going to find some midpoints, okay, to generate the iterations. So here I told you like earlier, it is a numerical subject. Numerical is all about the iteration. Iterations, I think you have understood in our Picard iterations. So first iteration, second iteration, like that we go until to get the uh, solutions what we are looking for. Okay, so that's what we're gonna do. Again we're gonna divide it by the midpoint and analyze the concept. Okay, so I'm just waiting for our meeting to finish. If it is finished, please join us. We can talk about again. Okay. Yeah, I'll talk until that. This is a pictorial view of these things, okay? So since this is a one variable, okay, this is, let's talk about x variable, and the functional value will get as a f of x, okay? For example, if I'm talking about this a and this b, my f of a will be, let's say, here. Okay, my function, let's say my function is this way. Okay, it's go here and there, but I am talking about this value now. So my FA, let's say this is my FA, this is a positive one. Let's say this is my B, I'm getting negative value. So this is okay. I can work in this area, I mean in this interval. Then what, see this point, this is a f of x, no? Here f of x equal to 0 point. So this is my R. My root will be here. But I need to do some work to come from here to reach here. Okay, that's what our idea of finding this. Also, so this is talking about what I have told you. So midpoints, okay. So C naught will be A1 first A and B divided by 2. Then again I need to go again until to reach what the questions ask about. Okay, what the question, according to the question, our iteration will be changed. Sometimes we may get the answer in one iteration. Sometimes we need to go more. Okay, so that's what the idea of this bisection method. Hope you'll enjoy to do some calculation. In between, please have your calculator with you. Okay, we need calculators to do this process. Otherwise, it's a long process. Anyway, you can't count, solve yourself it mentally, because it is a long, decimal points. There are more decimal points comes, so we can't do manually. So it's better to have the calculator with you in between times of we are starting our next sessions. Okay. Okay, we have, I think, 3 minutes. Okay, can go up to 3 minutes. So please read this working rule. Like our EDE, we have some working rules to do the things now. Solution methods. Likewise, bisection method also has some working rule, which has, let's say, four working rules. Okay. First one is find the point A comma B. Sometimes they may give you the A comma B. Otherwise, you have to find, likewise, what I have told you. You have to find A comma B, that is A less than B. And also, if you substitute FA and FB, then if you multiply both, it should be less than 0. Okay, that is our first step. Next, step number 2 say, take the interval again, that A comma B, and find the next value, this midpoint value. Okay, that is can be A plus B divided by 2. Then that C naught be the midpoint of A and B. Okay, that is our step number 2. Then step number 3 say, if you, let's say my A is equal to 1 and B is equal to 2, no? What is my C? 1 plus 2 by 2, isn't it? 3 by 2, 1.5. So if I put again to that 1.5 into that, let's say this is my z, because it's going z naught, c naught, c1 like that. So we are taking f of c naught. Let's say if it is 0, we stop. We got that. That is the root. We don't need to go other iteration. Okay. It happens sometimes. Okay. Rarely it happens. If you get the midpoint, if you substitute, if it is 0, that is the exact root. You don't need to go again. Okay. So that is one case. Another case, if it is not equal to 0 only, we have to do these processes. Okay. So then we have to see, okay. So let's say this is my A, this is my B, this is my C naught. Okay. So, okay.